Alright, hello. Today I am going to be solving, like I said in the last video, the Laplace transform of cosine. So I went ahead and started drawing off with the Laplace transform of sine. So now I am going to proceed to doing the Laplace transform of cosine. So, like I said, right, um, you have a you have an Euler identity for sine. You have an Euler identity for cosine. This is the given one for cosine right here. Um, and that's what we were going to be utilizing to do our Laplace transform using the Laplace transform definition. So let's go ahead and get this started. So I'm going to go ahead and rewrite this in parentheses e to the j omega plus e to the negative j omega over 2 times e to the negative st dt. Right. So right off the bat, I can actually go ahead and factor out my 1/2, rewrite this, it's still in parentheses, keep things organized, times e to the negative st. As y'all can see, right, we can go ahead and combine our two exponentials and make this into two different integrals. That'll make things a lot easier to see, right? So let's actually go ahead and box our inside, leave the 1/2 outside. So go ahead and rewrite this as e to the minus j omega plus e. Actually, yeah, I'll just go ahead and do it like this. E negative s plus j omega t. Let's not forget our t, right? dt. So that's what we have so far. Now we can actually go ahead and break this up into two integrals, right? So, to be efficient, e dt. Don't forget about your dt, right? And so now I'm just going to go ahead and rewrite this, right? Or write the second half. Actually, I almost made a mistake right there. Forgetting my plus. E. There we go. Okay, so that's what we have so far. Okay, so now it's easier to see this. It's definitely a lot more relieving, right? Because now all you have to do is compute two easy integrals, right? That we pretty much know how to do. There's not much to computing this integral and then evaluating the limits, right? So let me go ahead and continue. So we're gonna have 1/2 and integral of this, right? Of e of exponential of this exponential is going to be 1 over s minus j omega e to the negative s minus j omega t, right? And this is going to be evaluated from t equals 0 to t equals infinity, right? So over here, same story, right? Minus s plus j omega e to the negative s plus j omega t, right? And this is going to be evaluated from t equals 0 to t equals infinity, right? So that's what we have so far. Ahead. There we go. That matches just a little. So now all we have to do is evaluate our limits, right? So in this case, right, again, I'll go ahead and rewrite this 1/2. Fundamental theorem of calculus, right? S minus j omega, and this is going to be e to the negative infinity minus minus, right? That equals to a positive 1 over s minus j omega e to the 0, right? That's our first integral. So now let's go ahead and go on with our second part. So we're gonna go ahead and have 1 s plus j omega, right? And this is going to be e to the negative infinity. Negative, right? Again, I have a positive. 1 over s plus j omega e to the 0. And this is what we have, right? So now, e to the infinity, this is going to go to 0. Again, e to the infinity is a 0. E to the 0 is 1. So it's going to be 1. It's going to be 1. So what we have left is 1/2 1 over s minus j omega plus 1 over s plus j omega. That's what we have, right? So now, like we did in the last video, you're going to go ahead and do some simple algebra. We already went through the most challenging part, which was just basically calculating that integral. So now we get to the baby steps, right? This is just high school 101 again. So pretty much we're going to go ahead and simplify our two fractions. So in this case, right, we go ahead and go through the process. So we're going to go ahead and have s plus j omega plus s minus j omega over s plus j omega s minus j omega. So what we have so far, right? So this is going to turn to 2s over j omega are going to cancel. See? Actually, let me write this a little bit clearer. 2s up top, right? 2s. So now we're going to go ahead and have s squared minus j squared omega squared. Now we can actually go ahead and cancel our 2's. And so what we have left, right, is going to be s over s squared minus j squared omega squared, right? However, remember, j squared is imaginary. Therefore, that's going to be -1. Therefore, our final answer will be s over s squared plus omega squared. And this is the Laplace transform of cosine. And this should wrap up the 2 videos on how to calculate the Laplace transform of sine and cosine using the definition. Thank you.